Hey friends, welcome back to Civil Engineering Mastery. In this video, we are going to discuss about concrete mix design for M25 grade concrete with all the step-by-step procedure as per IS-456-2000 and IS-10262-2019. So without delay, let's begin now. Before starting the design, let's look into the required data. Grade designation is M25. Type of cement and grade of cement is OPC 43 grade. Maximum nominal size of aggregate is 20 mm. Exposure condition is moderate. Minimum cement content is 300 kg per meter cube as per IS-456 table 5. Workability in terms of slump is 100 mm as per IS-456-2000 class number 7.1. Transportation time is 30 minutes. Method of placing the concrete is pumping. Standard deviation is 4 Newton per millimeter squared as per IS-10262 table 2. Type of coarse aggregate is crushed angular aggregate. Maximum cement content is 450 kg per meter cube as per IS-456-2000 class number 8.2.4.2. So this we need to check. We know the minimum cement content and we know the maximum cement content, and we need to calculate the actual cement content required, and then we need to check whether it is satisfying the minimum cement content and maximum cement content values. Water cement ratio is 0.5 as per IS-456-2000 table 5. Fine aggregate zone 2. Next, let's look into the test data of materials. Specific gravity of cement is 3.16. Specific gravity of fine aggregate is 2.46. Specific gravity of coarse aggregate is 2.73. Specific gravity of water is 1. Admixture type is super plasticizer. Now let's look into the steps which are involved in concrete mix design. First, we need to calculate target strength, and then water cement ratio and water content, and then calculation of cement content. After that, we need to calculate the aggregate proportion between coarse aggregate and fine aggregate, and finally we need to do the mix calculation. These are all the 6 major steps which we need to follow in concrete mix design. Now let's start with target strength. F-CK is the target strength. So to calculate that, we have two formulas. One is FCK plus 1.65S or FCK plus X. Among these two, whichever is higher, that value we need to consider as a target mean compressive strength at 28 days. Here S is standard deviation as per IS-10262-2019 table 2. We need to consider this standard deviation. In IS-10262-2019 class number 4.2, which is meant for target strength for mixed proportioning. So we need to consider this formula. F-CK is equal to FCK plus 1.65S or F-CK is equal to FCK plus X. So among these two, whichever is higher, that we need to consider as a target mean strength. Here F-CK is target mean compressive strength at 28 days and FCK is characteristic compressive strength at 28 days. S is standard deviation and X is factor based on grade of concrete as per table 1. So X is the factor which is based on grade of concrete as per table 1. So let's take these two values from table 1 and 2, standard deviation and factor. From table 1, we need to consider the value of X for M25 grade of concrete. The value of X will be 5.5 for M25 grade of concrete. Similarly, let's take the standard deviation for M25 grade concrete. So that is 4 Newton per millimeter square is the standard deviation. So standard deviation is 4 Newton per millimeter square, and from table 1 we need to find out the X value, that is 5.5 Newton per millimeter square for M25 grade of concrete. So let's find out F-CK, that is 25. This is the characteristics compressive strength of concrete. 25 plus 1.65 multiplied by 4 is the standard deviation, which is equal to 31.6 Newton per millimeter square. Next, let's find out FCK plus X. F-CK is equal to FCK plus X. That will be 30.5 Newton per millimeter square. So among these two, this 31.6 is the higher value. So we need to consider this one. So our target mean compressive strength shall not be less than 31.6 Newton per millimeter square at 28 days. Water cement ratio. Exposure condition is moderate as per IS-456-2000 table 3. And 5, page number 20, we need to find out the water cement ratio. In table 5, minimum cement content, maximum water cement ratio, minimum grade of concrete for different exposure with normal weight aggregate of 20 mm is given. So here for moderate condition, we have under reinforced concrete, we need to check the minimum cement content, that is 300 kg per meter cube. The same we have taken in the beginning. Minimum cement content is 300 kg per meter cube. Maximum water cement ratio. So for moderate condition, maximum water cement ratio is 0.5 and minimum grade of concrete is M25. So this is the three things we need to consider. Minimum cement content 300 kg per meter cube and maximum water cement ratio 0.5. Minimum grade of concrete M25. So for moderate condition, at least the minimum grade of concrete shall be M25. We can go even for M30, but minimum should be M25. Water cement ratio is 0.5. It can be reduced since we use admixture. As we have seen in the beginning, we have taken the admixture as super plasticizer. So since we are using the admixture, we can reduce the water cement ratio. So water cement ratio can be decreased by 0.05. So 0.5 is the actual water cement ratio. From that we can decrease this much, 0.05. So we get 0.45 as the water cement ratio. Next one is water content. As per IS-10262 table 4, we need to find out the water content. Water content per cubic meter of concrete for nominal maximum size of aggregate. So aggregate size is given here 10 mm, 20 mm and 40 mm. Water content is given in kg. For 20 mm aggregate, the water content is 186 kg. So this value we need to consider for the calculation of water content. Here there is a note which is given in class number 5.3 for the desired workability other than 50 mm slump. So whatever the water content we have considered here, that is for 50 mm slump. For the desired workability other than 50 mm slump, if the slump is more than 50 mm or less than 50 mm, the required water content may be increased or decreased by about 3% for each increase or decrease of or may be established by trial. So this we need to consider carefully. So the water content whatever we have considered is for only 50 mm slump. If the slump is more than 50 mm or less than 50 mm, we need to increase the water content or decrease the water content by 3% for each 25 mm of increase or decrease in the slump. For example, if the slump is 75 mm, see here we have the value from table 4, that is for 50 mm slump. For example, let's have a 75 mm slump. That means 50 mm plus 25 mm. Okay, that is 75. So we have 125 mm increase of slump. So in that case, we need to increase the water content by about 3%. Similarly, if the slump is 25 mm, that means the slump got reduced from 50 mm to 25 mm. If the slump is 25 mm, then it got decreased, right? So for that, what we have to do, we need to decrease the water content by 3% for each 25 mm decrease in slump. So 50 mm is the slump which is given. The values are given for 50 mm. If the slump value is increased, as we have discussed, 50 is the given slump and we have the slump value as 75 mm. So then from this it is increased 25 mm. So only one time it is increased 25 mm. So that is what it is given here. Each 25 mm increase or decrease. So one time 25 mm slump has been increased. So we need to increase the water content by only 3%. If it is a 100 mm slump, then we need to increase the water content by 6%. Like this we need to keep on adding. If it is a 125 mm, then we need to add it as, make it as 9%. If it is 150 mm slump, then we need to make it as 12%. Similarly, let's look into the example for decrease. 50 mm is the given one, and if we have the value of 25 mm slump, then we need to decrease the water content by 3%. So in this way we need to do. We need to keep on increasing the water content by 3% if the slump is increased by 25 mm. If the slump is decreased by 25 mm, then we need to decrease the water content by 3%. For 20 mm aggregate, 186 kg is the water content for 50 mm slump. As we have seen in the beginning, we have 100 mm slump. So for every 25 mm increase, these we need to add 3% as per class number 5.3. So for 50 mm extra, the given value for 50 mm slump. So here we have the 100 mm slump, that means 50 mm slump we have extra. Each 25 mm we need to add 3%. So here we have 50 mm, so we need to add 6%. So 186 is the water content for 50 mm slump. 186 plus 6% of 186. We get 197 kg as the water content. Next, the admixture we are using is super plasticizer. So for that we need to reduce 20% of water content. 187 minus 20% of 187, which is equal to 157.6 kg. This is also given in IS-10262. Water reducing admixture or super plasticizing admixture usually decrease water content by 5 to 10% and 20 to 30% and above respectively at appropriate dosages. Water reducing admixture means 5 to 10% we can reduce the water content. If we use super plasticizing admixture, then we need to reduce 20 to 30% of water content. We are using the admixture as super plasticizer, so for that we can reduce 20% of water content. We have calculated the water content as 197 kg. So 197 minus 20% of 197, we get 157.6 kg as the water content. We can convert this into liters as well. Water content is equal to 157.6 liters. Next, let's calculate cement content. Water cement ratio is equal to water content divided by cement content. So we know the water content and water cement ratio. From this we need to find out the cement content. So cement content is equal to water content divided by water cement ratio. Water content is equal to, we know we have calculated as 157.6 kg. Water cement ratio is 0.45. So cement content is equal to 157.6 divided by 0.45. We get 350.2 kg per meter cube, which is greater than 300 kg per meter cube. This one is the minimum cement content required as per IS-456 table 5. Since the cement content is more than the minimum cement content required, it is okay. So we need to consider the cement content as 350 kg per meter cube. Next, let's find out aggregate proportion between coarse aggregate and fine aggregate. So this we need to find out from IS-10262 table 5. In table 5, volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate for water cement or simultaneous material ratio of 0.5. So for that water cement ratio according to the zone, the value is given here. So nominal aggregate size is 20 mm. For 20 mm aggregate size, and our zone is located in zone 2. So for 20 mm aggregate size, we need to consider the value as 0.62. Here in class number 5.5.1 there is a note. Approximate values for this volumes are given in table 5 for a water cement ratio of 0.5, which may be suitably adjusted for other ratios. So everywhere we cannot get the water cement ratio as 0.5 because we will be having different exposure conditions, and according to that we need to use the water cement ratio. So for other water cement ratios, this volume has to be adjusted. So how do we adjust that one? The proportion of volume of coarse aggregate to that of total aggregate is increased at a rate of 0.01 for every decrease in water cement ratio or water cement or simultaneous material ratio by 0.05 and decreased at the rate of 0.01 for every increase in water cement ratio by 0.05. This will be little confused. If you listen carefully, you will understand properly. So the proportion of volume of coarse aggregate to that of total aggregate is increased at the rate of 0.01. If that is increased at the rate of 0.01, the proportion of volume of coarse aggregate to that of total aggregate is increased at the rate of 0.01 for every decrease in water cement or simultaneous material ratio by 0.05. Each decrease in water cement ratio by 0.05, we need to increase the volume of coarse aggregate to that of total aggregate at a rate of 0.01. Here it is vice versa. If the water cement ratio is decreased by 0.05, then we need to increase the volume of coarse aggregate to that of total aggregate at the rate of 0.01. Similarly, if the water cement ratio is increased by 0.05, then we need to decrease the volume of volume of coarse aggregate to that of the total aggregate by 0.01. In class number 5.5.2, it is given as for more workable concrete mixes which sometimes required when placement is by pump or when the concrete is required to be worked around congested reinforcing steel. It may be desirable to reduce the estimated coarse aggregate content determined using table 5 up to 10%. So if the concrete placement is pumpable, then we can reduce the coarse aggregate content by 10%. As we have seen in the table 5 of IS-10262, for zone 2 the value is 0.62, for the water cement ratio of 0.5. So every 0.05 decrease we need to increase 0.01. Every 0.05 decrease of water cement ratio we need to increase this value with 0.01. So our water cement ratio is 0.45. Let's find out how many decrease is there. So 0.5 minus 0.45 divided by 0.05. Each 0.05 decrease we need to increase 0.01. So that is why here 0.05. So that is 1 times only. So 0.62 plus 0.01, which is 0.63. For pumpable concrete, coarse aggregate can be reduced up to 10% as per class 5.5.2. So volume of coarse aggregate is equal to 0.63 minus 10% of 0.63. If we use a pumpable concrete, we can reduce the coarse aggregate proportion into 10%. So we get 0.567 as the volume of coarse aggregate. Next, let's find out the volume of fine aggregate, that is 1 minus 0.567, which is equal to 0.433. Next, let's do the mix calculation per unit volume of concrete. Volume of concrete is 1 meter cube. Volume of cement is equal to mass of cement divided by mass density. Now mass of cement is the volume of cement, that is 350.2 divided by mass density is specific gravity multiplied by 1000. We get 0.110 meter cube. Next one is volume of water. Mass of water divided by mass density. We know the mass of water as 157.6 kg divided by mass density, that is specific gravity multiplied by 1000. Specific gravity of water is 1 multiplied by 1000. So we get 0.1576 meter cube. Next one is volume of admixture. Mass of admixture divided by mass density. We don't know mass of admixture, so let's assume mass of admixture as 1.1% of cement, 1.1% of 350, that is 1.1% of cement as the mass of admixture divided by mass density. Specific gravity multiplied by 1000. 1.12 is the specific gravity. Up to 2 we can consider the specific gravity for super plasticizer. So if we calculate, we get 0.00343 meter cube as the volume of admixture. Next, volume of all in aggregate. We know volume of concrete, volume of water and volume of admixture. So volume of all in aggregate we need to find out. So 1 minus volume of concrete, volume of admixture, volume of water. 1 minus 0.110 plus 0.1576, this is volume of water, plus 0.00343. So we get 0.728 as the volume of all in aggregate. Let's find out mass of coarse aggregate. Mass of coarse aggregate is equal to volume of all in aggregate multiplied by volume of coarse aggregate multiplied by specific gravity of coarse aggregate multiplied by 1000. We know volume of all in aggregate is 0.728. Volume of coarse aggregate, which we have calculated in step number 5, aggregate proportion between coarse aggregate and fine aggregate. Here volume of coarse aggregate is 0.567 and volume of fine aggregate is 0.433. Specific gravity of coarse aggregate is 2.73 multiplied by 1000. So we get 1127 kg. Next, let's find out mass of fine aggregate. Volume of all in aggregate multiplied by volume of fine aggregate multiplied by specific gravity of fine aggregate into 1000. So volume of all in aggregate we know 0.728 and volume of fine aggregate is 0.433. Specific gravity of fine aggregate is 2.46 multiplied by 1000. So we get 775 kg as a mass of fine aggregate. Next, let's look into the summary. Cement is 350 kg per meter cube. Water is 157.6 kg per meter cube. Fine aggregate is 775 kg per meter cube. Coarse aggregate is 127 kg per meter cube. In this 20 mm 60% we can take and 10 mm aggregate 40% we can take. Admixture is 3.85 kg per meter cube. This is 1.1% of cement. So if we calculate 1.1% of 350, that will come as 3.85 kg per meter cube. Water cement ratio is 0.45. Let's look into the ratio. Cement is 350, fine aggregate is 775, coarse aggregate is 127, water is 157.6. Cement is 1 and fine aggregate is 775 divided by 350, that is 2.2. Coarse aggregate is 1127 divided by 350, that is 3.22. Water cement ratio is 157.6 divided by 350, that is 0.45. So this is the mix ratio for M25 grade of concrete. So friends, in this way you have to do the mix design calculation for M25 grade of concrete. I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. And if you like this video, share it with your friends. Don't forget to subscribe the channel for more videos. Thank you for watching.